Hi, I'm Jay. This is CNPi, 3D CNC machines with Raspberry Pi. So our project uses a Raspberry Pi to dynamically change the feed rates on a CNC machine to reduce chatter. So this is our demo, I guess. So yeah.
So if you look at this is our Pi setup. We have a the Pi only has serial connections or USB connections, but the CNC computer and the mill use serial connections. So we have a serial to USB adapter, and we have two of them. One is hooked up to the computer, and the other is hooked up to the CNC mill. And also we have our microphone here to detect the noise. And yeah, so basically we're going to be recording we're going to be forwarding information from the CNC to the computer and vice versa, so that both of them are like talking to each other, and like we're going to be recording the data so we can like modify the instructions to decrease the amount of chatter we get. And we're going to be using the audio recording and to determine how much chatter we're getting. So we're just going to do like an FFT on the audio file that we record and figure out like at which points we're getting too much chatter.
So we're going to demo the thing right now. So you're going to start the program. So this is the CNC machine. So I have it all set up, the G-code program, and now I'm going to start the transfer. So that starts the transfer. So now the CNC is sending a request to the computer, which the Pi is intercepting, and then the Pi forwards that request to the computer. Then the Pi gets the data the computer sends back, buffers it, stores it into a file that can be used later, and then also forwards that data to the CNC. So now the CNC is running, and running the program. It should be pretty nasty. So it is doing just a horizontal cut, and it's gonna have a lot of chatter. So that was just the program right there, pretty simple. So now the Raspberry Pi detected it, so it will render what the program was. So it took in the G-code and created this 3D render of it, which we could explore. And so now so you could actually rotate this and stuff, and it's pretty fast now, but when you have larger programs, it does slow down. Okay. So then to get to the next step, you have to exit out of the program there, and then now it's going to start generating the spectrogram, and the spectrogram will show us the frequency that it picked up. So you can see that it was picking up a lot of frequencies between 0 and 2000, which is, according to our research, where the most where the most noise is. Also, you can see here how it increased the noise there. That's because I actually turned up the feed rate a little bit on the machine manually. So you can see that it is sensitive enough to pick up these frequencies. And so then the next step is to recompile the program based on this information.
So is that from the microphone?
Yeah, so this is from the microphone that was picked up.
Okay.
So even though the microphone was not in an ideal location, ideally we'd actually put the Pi either inside of the machine or as close to the machine as possible. It still was able to pick up all that information. And so now we're going to recompile the program. So basically what this does is it takes the serial data you have and it calculates estimated times for when each instruction is being executed, and then maps that to the spectrogram data. And so then you could get the magnitudes and the frequencies and figure out which instructions are causing the bad noises, and then you can adjust your feed rates accordingly there. And so so now it's done. And so now we could view the new file. So if you cat fake.min, and so enter. And so right now it actually did not recompile any of the code, probably because it didn't. I set the thresholds too high for noise. But if it did think there was too much noise, it would actually recompile the code.
Should I pause?
So
Pause.
alright, so I guess it just didn't recompile there because it didn't experience enough noise. But we'll have examples where it actually recompiled. We'll upload it to the report. So that's CNPi. So Thanks for watching.